Today I've got something pretty dang awesome. This. It looks pretty boring, it's very simple, but what this is, 400 volt, 2000 microfarad capacitor. If you charge this in 350 volt, in terms of energy, it's about the same energy as you get from .22 long rifle bullet. That is just fantastic, isn't it? Now, I have a very simple circuit here. Power supply supplying power to the capacitors, and that goes to the LED. I'm gonna turn this on and see how long this will stay on. And hopefully, it's large enough to use it like a battery or something. Actually, that was much shorter than I expected. But if you charge this at very high voltage, which is going to start from now, but if you charge this at very high voltage, which is about 315 volt at this point, it's going to pack a lot of energy, like I mentioned before. And for this demonstration, I get to wear a fancy ear muffler like this. This is about 100 joule release into light and loud noise in very fast moment. Expect to see some fancy stuff. It's pretty cool. I don't know if the camera can pick it up from there, but this clip is halfway melted, and as well as this clip over here. So that pack a dang lot of energy. Now, of course, you don't want to do that every single time you want to discharge this capacitor, because reason number one, it's inefficient. It wastes all that energy into light, smoke, smell, and where actually smoke and smell part comes from the heat, which is also a waste of energy, and of course the sound. So instead, what you want to do is use this thing called MOSFET. So right now this capacitor is charged at very high voltage, so I have to be extra careful. I'm gonna connect this LED over here to the positive side. And then I'm going to connect a wire to the negative side. And I will connect this to the drain of the MOSFET. I will also connect this terminal to the source of the MOSFET, but not yet, but because with having that connected, if the MOSFET opens up for absolutely no reason, can get a little ugly. So now I'm going to connect this, see if I have enough space here, over to the source to match the grounds, and power, which is already connected to the gate. Extra careful to not short anything. Now finally, I will connect this negative terminal of the MOSFET, I mean not the MOSFET, the capacitor, to the source of the MOSFET. Then what's going to happen is nothing. Hopefully nothing, actually. Yeah, nothing. Alright, now everything is set up. When I press this button, it's going to turn on the MOSFET and it's going to blow that LED up. Yep, I called it. I'm gonna discharge these. Still had a lot of energy in it. Okay, so this is what's left of the LED. It's got separated into two pieces because that die exploded. And interestingly enough, this MOSFET also exploded, which gives me a good chance to look inside the MOSFET. This seems to be just a piece of plastic. That's probably the drain, and there's probably silicone somewhere. Yeah, pretty cool. But this is not what I intended to see. So there were some miscalculations in this process. About 330 volts and 2000 microfarads. So I get about 100 joules. That is the correct part. Now, what is basically equal to joule per second? Joule, we have about 100 divided by time, which is 0.001 second, will give us about 100,000 watts. Now I know this is discharging at about 330 volts, so I will divide that by 330 volts, get 303 amps. STK730 is the MOSFET that I've been using. This is the mistake I made. The maximum drain current burst was rated at 22 amps. So 303 amps will definitely blow that MOSFET up. Although drain source voltage is rated at 400 volts, so that's not going to be a problem. Now I have this other MOSFET, IRF540. This will be able to handle up to 110 amps pulse, so I will only need about 4 of them to make sure it doesn't blow up. But drain to source voltage is limited to 100 volt, so this will also blow up. So I guess the best bet here is to use the STK730, which was rated at about 22 pulse amps, and then connect them in parallel. Connect about 10 of them in parallel, where actually that's still not enough. That's going to be 220. So say connect about 20 of them in parallel. I think that's the best bet that we are going to discharge the capacitor without, seeing fancy lights and loud noises going everywhere. So while running through a box that I put usually stuff that I, had fun with in the past, I found this, which is basically about exactly 10 MOSFETs in parallel. You can see the soldering is really not good. You know what? On the second thought, I might just go ahead and try to use this MOSFET to discharge the MOSFET because number one, I don't want to work on soldering 10 MOSFETs in parallel again. I can see the painful me inside that thing. And second of all, all my calculations are based on the discharge will occur within 1 millisecond. But if it's discharged in 2 milliseconds, the pulse current is going to be about 150 amps, and this MOSFET will be able to handle that. If I'm wrong, all these MOSFETs will explode. If I'm right, these MOSFETs will not explode, only the LED will explode. We should give it a try. Whoa, what the fuck was it? Okay, so that resulted in a few conclusions that I can make at this point. Number one, my ears hurt. Number two, there was definitely an absolutely more energy went through the LED than the previous one, because you can see it got split into 3 pieces, and probably that's because there is more energy. Ow, my ear, it really hurts. I should probably go see a doctor after this.